we'll get started. All right, so to simplify rational expressions, if you recall, you never divide with fractions. You always change it to multiplication by the reciprocal. Okay, so this becomes x plus 1, x plus 7. This changes to multiplication. We use the dot. Okay, I'm back. And then you flip the one on the right here, x plus 7 over x plus 3. You see any cancellations?
Can you cancel the x plus 7?
Yes. Because it's a multiplication, you can cancel anything that's the same in the top and the bottom. And there's your answer. It's x plus 1 over x plus 3. All right, so there's one kind of off to the right here. It looks like you already did. It's really similar. Once you've seen one, you can almost visually do it, but it's good to write it out. X plus 4 over x plus 6 times x plus 6 over x plus 9, like that. And again, cancellations. So x plus 4 over x plus 9. Now, there's a small thing here that you're supposed to be restricting the domains. I don't really know if you guys are doing that. It's there's not really much here to go to say, so I'll just keep doing what I'm doing here. This one is related. You have to simplify the top and simplify the bottom first by factoring. Everyone's favorite, factoring. So do you remember how to factor the numerator?
Do you just write it out like x times x?
You do a bit different than that. I mean, that would be true in some situations, but not for this one. It's difference of squares, and that is a formula. So I'll write it here off to the side here. A squared minus b squared equals a minus b, a plus b. So does that help at all?
Yes. I think I remember.
What goes in the top?
Would it be? Would you do the same thing except just like add the x's?
So your x squared minus 36 is like x squared minus 6 squared.
Oh, okay.
So help me out here. I don't want to do the whole thing for you. So what does it become? What is A? What is B?
So for the first one, is it just x minus x?
A is x, that's for sure, but B is not x. It's 6. Yeah.
Oh, so it's x squared minus 6 squared.
Nope. No. So notice there's no squares in here. No squares.
So then it would just be without the squares.
Yes. Yes, like this. Okay, so that's the top. So there is some expectation that, that factoring you learned back in Algebra 1 that you did again this year, that's like fair game on these finals. Now the bottom is a different type of factoring. I call it A equals 1. You're looking at the last number and the middle number. You're trying to find two numbers that multiply to 24, but then add to positive 10. Does this sound familiar to you?
Yes.
Okay. So the 24 you can break apart, 1 and 24, those multiply to 24, 2 and 12, 2 times 12 works. And you keep going. There is some pair that will work and also add to 10. Can you work through that list and let me know what you come up with?
wait. Is there a number are there two numbers that perfectly turn into 12?
It's 24. Like just go down the list. Just take 24 and divide it by 3. 3 times what number gets you 24? Then add them together. And then do the same thing for the next one. Like you just keep trying numbers until you get it.
Would be 64.
So they're the only ones that add up. So you write up plus 4, x plus 6. And then again, you look for any cancellations. And again, you do have a cancellation. You cross those out. So if it's the same on the top and the bottom, you can get rid of them. All right, so let's look at one more. It's a nice healthy review. Lots of problems here. This is a nice thing is this is just like the last one. So it's going to be the same situation. You've got to factor the top, factor the bottom. The top is again difference of squares. It's just like the previous one. It's an a squared minus b squared becomes a minus b, a plus b. All right. Can you tell me what the numerator becomes?
X minus 121. And
So
then
it's the number that you square to get to 121.
oh.
All right, so that it is 11 squared. So it becomes x minus 11, x plus 11. All right, now the bottom is kind of like the last one. You're looking at that last number there, 55. It's going to multiply to 55, but add to negative 16. Okay, and that's where I think it's a little bit different, maybe uncomfortable. It's like, how can something multiply to 55 but then add to a negative? Well, they're both negative. For example, -1 and -55, those multiply to 55, but it does not add to negative 16. So you have to keep going down this list. If you got a calculator, you take 55 and divide it by 2, and then 3, and then 4. And eventually you find something that will work. This is not an impossible problem. So could you attempt to find that factor for us, please, or those numbers?
-11 and -7.
-5, -11, that is correct. Now, you might have noticed, just like in the previous problem, that there's likely going to be one that's exactly the same. And that's kind of your hint. That's your like, okay, if I got something in the top, it's probably going to be in the bottom. You might use that to help factor, like, okay, one of them is going to be 11 or one of them is going to be -11. Just like in the previous problem, it's like to get to 24, one of them is either 6 or -6. Okay, so this just cancels out and you have x plus 11 over x minus 5.
Okay.
Right. Any questions that before we move on to a new topic altogether?
No.
Okay. So we're looking at a bunch of graphs now, and this is your sine and cosine part of the course. So hopefully it's a little bit on my screen. There's a little bit of a slant to it, but on your paper, you can see it right in front of you. You've got to identify a bunch of things here: the midline, the amplitude, the period, and so on. So we'll do these. We'll do these together here. The midline. The midline is the min plus the max. Actually, let me change the order. Let me write max plus the min. Max plus the min divided by 2. And that refers to the y values. So you need to find the peak y value and the smallest y value. What would those be in this problem here? Just the y values.
0 small.
0 is the smallest. How about the max? What's that y value there at the top?
I think it says 4.
Looks like it's 4. Yes. All right, and then you divide by 2. So this ends up equaling 2. And notice that if you draw kind of, if you have this in front of you, or you know, I'm going to do my best here. It sort of splits it in half. The top's the same as the bottom in terms of like it goes up the same, comes down the same. That's what the midline means. The amplitude is really similar. It is the max minus the min divided by 2. So notice one's plus, one's minus. You got to know the difference. Sometimes you get the same result. 4 minus 0 over 2 is 2. So the amplitude represents this sort of distance from the midline to the top or the midline to the bottom.
Okay.
Now, that is 2 of the things. The third thing they're asking for is the period. So we're kind of done with the y value stuff. For the period, you have a couple of options here. You can go peak to peak, valley to valley. You can pick a point and get back to it. This one looks best to go valley to valley. And what I mean by that is you pick 2 points and you go right minus left.
Okay.
So the right here is the x value, 5 pi over 4 minus pi over 4.
Wait, where'd you get the pi over 4?
The right over here minus the left.
Oh,
So
okay.
when you find the distance between 2 things, you always choose the one that's further out and subtract the one that's closer to you.
Uh-huh. Okay.
All right. So what does that subtract to?
4 pi. Would it just be pi?
It is, yeah. It's 4 pi over 4, which is just the pi. So that is your period.
Okay.
Okay. The next thing is to decide. I'm gonna use the same snip here. Talk about this. Is deciding whether it's a sine or it's a cosine. So let's talk a little bit about what makes something a sine. Sine starts at the origin, or think of this as the center line. Now it goes up and then goes down. Okay, but this is also a sine where it starts down and comes back up. That's also okay. A cosine, and again, you're thinking of it as the center line. You want to look at as a reference from the center line, not the origin. It starts high, goes low, and comes back up. But it can also be flipped and start low, go high, and come back down. Okay. What you have to do is look at this thing relative to the center line and decide, well, what is it? Is it starting at the center line or is it starting above or below the center line? So notice the sine starts at the center line.
Mm-hmm.
The cosine does not.
It's starting.
Yes. So this would be some sort of a sine. And the nice thing is you actually don't, according to this, it doesn't, you don't have to actually write the formula, which I can't believe, but we would say it's a possible sine.
Mhm.
Reason I say that, I mean, that's kind of the whole point. They give you the graph, you write the equation, they give you the equation, you draw the graph.
Yeah.
Any questions on that before we move on to the next part?
Yeah, I don't have any questions on that.
Okay, so the next is to find a rule for all the x-intercepts. So the rule for the x-intercepts, basically want to know, like, how can you predict the new x-intercepts? There's one at pi over 4 and then 5 pi over 4. Do you see the pattern, like what it's going up by? And you actually already answered this. It's the period.
So it's just pi.
It's pi. So you have to add pi to this each time. But rather than adding pi, it's probably better to think of it as 4 pi over 4. So the next
Mhm.
one would be 9 pi over 4, 13 pi over 4,
You have to
and so on.
multiply them.
You're just adding. You're adding pi. So like, let me show it here more explicitly. So pi over 4 plus 4 pi over 4 is 5 pi over 4.
Mm-hmm.
5 pi over 4 plus 4 pi over 4 is 9 pi over 4. You're just
Okay.
adding the period each time.
Okay. Got it.
So that is it for this one. All right, so we'll do another one here.
Yep.
All right, so this is a new problem here. We started out by doing the midline. The midline is the max plus the min divided by 2. Could you tell me the midline, please?
Yep. 4.
It is 4. 8 plus 0 divided by 2 is 4. I like to draw it. This one doesn't have a great like increment, but you can kind of eyeball it and say, yeah, that's about right. Okay, the amplitude is the max minus the min divided by 2. If you don't like that formula, you're afraid you might not remember it. It's also the distance from the center line up or the distance from the center line down.
Mm-hmm. So it's just 4.
Yeah, happens to be 4 again, which
Right.
it's not always like that.
Mm-hmm.
These are not the best ones here. Okay, period. I would recommend using for the period these 2 points to calculate the period. So you want to give that a try, please?
Yes.
That's
Well,
right,
you did.
right
Okay.
minus left.
Oh. Okay. Would I simplify it? When I simplify it, I just get 3 pi over 1.
Could be 3 pi. Yes,
Okay.
that's correct. Okay. So the periods, let me just write that in case you want to look at that later in your notes here. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2, which as you mentioned is just 3 pi. Good. Okay. The next thing it asks for in this list here is whether it's a sine or cosine. So really you just go back to this center line and decide, is it starting at the center line or is it starting above or below the center line?
It's starting above.
Yes, so this is a possible cosine.
Hmm.
I guess that's sufficient. Um, I'm laughing because I mean, they really should like, well, the reality is it actually could be either if you, but you'll see that maybe if you take another course in trigonometry or calculus, but
Yeah.
anyway, nevertheless, that's not what they're asking. So the next thing is the x-intercepts, and there's this pattern. It's 3 pi over 2, and then 9 pi over 2. And we said in the last problem, it's going up by the period. You're adding 3 pi. Could you give me the next one in this list?
Yeah. Um. Six pi over 2.
Okay, you're adding that to the 9 pi,
I'm adding it to the
9
9
pi
pi
over
over
2.
2.
Yes.
Hello?
Yes. Do you have an answer for me?
Oh yeah, I said 6 pi over 2.
Yes, but you have to add that to 9 pi over 2.
Oh, that's what I did.
Well, can't back, you can't get the same number back unless you're adding 0. So let me be clear, 9 pi
Oh.
over 2 plus 3 pi, which is what you just said. It's 6 pi over 2. I'm asking you to add those together.
Oh. Wait, why are we adding those together?
I was asking you to give me the next one in this list. See the intercepts repeat, 3 pi over 2, the 9 pi over 2, and then the graph keeps going, right? It's gonna hit down here again at the x-axis. I'm just asking you to tell me what the next one is to see if you understand the pattern.
15 pi over 2.
Exactly. Now, one of the things you start noticing when you do a bunch of these is that there's this increment that's going up each time. It's you're adding the top number by 6. So the next one is 21 pi over 2, and then 27 pi over 2. And you are adding 3 pi each time. You're just patterning it. And in the
Okay.
previous one, it worked out exactly the same.
Mm-hmm.
So that's another way to do it if you don't like the adding the pies, it can be cumbersome to do, frankly. I mean, it's weird enough to be using pies, but then fractions make it all the worse. So
Yeah.
all right, let's do another one here. All right, so it should go a lot faster here. What is the center line? What is the center line in this one? And you don't have to use formulas, you just got to kind of figure out where's the center? Where does it kind of split top and bottom?
-3. Would it be -3?
Yes, very good. It's -3. You can always use the formulas, which is the max plus the min divided by 2 gets you back there. How about the amplitude?
Just 3.
Yes. So this time it's different. Thank goodness. How about the period?
The period. Oh. Mm. Um. Is it just pi?
Right minus left. Period is the right value minus the left value. And you're choosing two places that are the same, meaning like either the peak to the peak or the valley to the valley. We don't have the other valley, so it's got to be
Can
peak to peak.
when I'm subtracting it, do I have to like get the 1 and the 5 pi to like be a 2?
So think of it as in terms of like x's. If it were 5x minus 1x, you would say, oh, that's 4x. It's the same thing here. You have to keep a pi in your answer. You're really just subtracting the 5 and the 1.
I got 9 pi over 2.
Okay, we're just taking 5 pi and subtracting 1 pi. It's the same as me asking you like 5 minus 1.
Oh,
Yeah. There's
I don't
nothing.
know why I wrote it as pi over 2. Okay, that makes sense. I thought that was a pi over 2 for a second.
Yeah. So just circle the points or indicate the points. That way you're using the right values, however you want to do that. All right. Now, is this a possible sine or cosine? Again, I've drawn the center line here. That's kind of the key doing it.
Sine.
Here's the sine. Good. So it's a possible sine. All right, not super helpful, but okay. So the first x-intercept is at pi. And then the second x-intercept they show you is at 5 pi. And we've talked about this a couple times now. It's always going up by the period. Could you give me the next x-intercept?
Yeah. Would it just be 9 pi?
And then it might be 13 pi, and then it might be 17 pi. You're just going up and up and up. Good. Okay. So we're on to page 2, more graphing, unless you're tired of graphing, and then we can go to logarithms.
Is the next one like the tangent?
Yes.
Okay, yeah. I wanted to go over that because I like completely forgot about that lesson.
Sure. All right. So you got a really good start here with your parent function. One thing I'd like, so the one thing don't really like here is that they've got these here. You're really supposed to use those. That's where the vertical asymptotes are supposed to go.
Okay.
And then, but you have the shape right. It is like this. It's a snake. That's what I kind of think of it as. And there's 3 key points that you're supposed to include. And you've got them all here. There's -1, negative pi over 4, 1, and pi over 4. You have to know these 3 points. You can obviously plot that one, plot the 1
Do
pi
you
over
use
4.
those every time?
Yes,
Okay.
those are the main ones to shift. The other ones are really hard to shift, so we're not going to do those.
Mhm.
The other thing to notice, I guess, and you kind of have enough from there. There's another asymptote over here at 3 pi over 2, and it's the same exact graph. It's repeated. Same thing if you go left to -3 pi over 2. It's repeated. Now you only have to graph 1 full period. Like this is extra. I just want you to see that before we go to the next one because it's somewhat related.
Mhm.
Is that okay?
Yeah. I
All
guess
right.
I'm just like confused on what the vertical asymptote means. Like,
So tangent of x is really sine of x over cosine of x. And you learned a long time ago that you can never divide by 0. Okay.
mhm.
And the problem is the cosine of pi over 2 is 0. So when you get to cosine of pi over 2, you can't divide by 0. That's why there's an asymptote here, because it's undefined.
Okay.
The tangent is completely unrelated to sine and cosine in the sense that sine and cosine are really nice. They're really nice and smooth. These have a lot of issues,
Mhm.
but tangent comes from sine and cosine. But to answer your question, the reason the vertical asymptotes exist and what are they? They're the issues when cosine equals 0. Do you want
Okay.
me to show you another graph? I think I could show you a quick graph to make this more clear. Let me do this here. I'll snip it in, but if I can. Wow, why am I? So let me grab a snip of this. Hopefully this will help. Good question. Could have been explained in the classroom, of course. So notice that pi over 2 cosine is 0. And that's where this asymptote is. So whenever cosine hits 0, there's an asymptote. And that's because tangent is undefined when you divide by 0. All right, so let's get back to your graph here. So one of the things I think that they're expecting you to do, even if you don't write it down or get a grade for it, is to write the transformations.
Mm-hmm.
This one has 3 transformations. Can you tell me any of them? Take any of them for this one.
Up 3.
Okay, that's the last one.
Left pi, I guess. I
Yeah,
don't
left pi. That's right. Good.
know. And is it a shrink of 2?
The stretch, vertical
Or
stretch
Okay.
of 2. Okay. All right. Now I think I actually do need to share the screen for this part. So let me quickly new share. I'm showing the Desmos calculator. We can also do this on scientific calculator. I've got a virtual TA83 if we need to, but you've seen me graph tangent of X a bunch of times. Okay. Now, if I add pi to it and I graph it, what do you notice?
Um.
There's the original in black,
Mm-hmm.
and then when I make that visible, there's the red. What do you see?
Did they like it like stretched more, I think? I'm not sure.
What do you do when you see someone wearing the exact same shirt you got on? You say it's the,
Like it's
well, maybe you say something foul, something like that. Maybe you're upset, but it's hey, it's no, they're the same. They're the same, right?
Oh, okay.
Aren't they exactly the same?
Yeah, I just got confused for a second.
Okay. Now that's plus pi. What do you think happens if I go minus pi? Any
Oh,
guess?
maybe it's like the opposite way.
What do you see?
It's like the same.
It's the same. Yeah. Okay. And the reason is tangent, every pi is it's got a period of pi, so it repeats every pi. So even if you move it to the right 2 pi, it's still the same.
Mm-hmm.
3 pi, it's still the same. 4 pi, it's still the same. And that's because it keeps repeating every pi. So it doesn't really matter what you change it. So, okay, enough on that. Let's go back to your problem. So the thing is this does not impact the vertical asymptotes at all. And I think that's the reason the instructor chose this problem, is because they knew that it was the exact same graph as the parent function, because the plus pi, the minus pi are exactly the same.
Mm-hmm.
Okay. Now, we do have to do some things with the vertical stretch and the up for each. So that's why I had you write the parent function here, -1. Sorry, that's not right. Wow, this is really bad. I apologize. These are backwards. It's been a long day. So sorry. minus pi over 4 is -1. 0 is 0. Pi over 4 is 1. Okay, so we need those down here, and we have to appropriately transform this. So the vertical stretch of 2 affects the y value. That causes the y value to be multiplied by 2. So that's -2.
Mm-hmm.
That one doesn't change, but this one becomes 2. So we've taken care of that. And then the next thing, up 3, causes the y value to go up by 3 each time. So you're going to add 3 to
Mm-hmm.
each of the y values, keep the x values.
Does nothing happen to the egg?
The only thing that affects the x is the left pi over left pi, but that's what it's showing you graphically. It's just a repeat each time.
Oh, yeah.
Okay, so what that means for in terms of the graph is sometimes it's good to draw the parent function and then just kind of show, okay, it's pulled, the new graph is shifted up and pulled. I mean, you don't have to be super exact, but there's 0, 3 minus pi over 4, 1. You're showing something that kind of looks like that.
For
And there,
the stretch of 2, did you multiply it by 2?
yes, that's exactly
Okay.
what I did. Good question. Multiply by 2, add 3.
Okay.
That's it. Any questions on that? Do another
No.
link here. Okay. Let me go grab the next question here. All right. All right, 3 tangent x minus pi minus 4. But that minus pi, it moves it right pi, but we already know that if you move it right pi or left pi, it's the same graph.
Yeah.
So even though we write it as a transformation, it actually doesn't affect anything. It's right pi this time. What's the 3 in front of the tangent x? What does that do?
It's a stretch.
It's a vertical stretch of 3. All right, and -4, what does that become? What does that do?
Down 4.
Down 4. All right. So now normally right affects the x, but we've already said that doesn't affect anything. The vertical stretch affects the y, you multiply by 2. The down 4 affects the y, you subtract 4.
Mm-hmm.
So here's the parent function again. Minus pi over 4 minus 1, 0, 0. Pi over 4, 1. Can you give me the new y values after these transformations? And the order does matter. You have to first multiply by 3 and then subtract 4.
Subtract 4. Okay.
Yeah. What would the new y values be?
The first one would be -7.
Okay, I agree.
And then -4.
Good.
And then just -1.
Good. Okay. So you plot those points, 0, -4 is kind of right there. We actually don't have room. Typical, they don't give me enough room for for these. The main thing is to show kind of a snake, like it's got to kind of bend a little bit like that. Any questions on that before we go to the last graph?
No.
Okay. All right. why don't you do the transformations here, meaning just give me the new ordered pairs here, minus pi over 4, minus 1, 0, 0, pi over 4, 1. Why don't you give me the new ordered pairs, please?
Okay. Okay, it's -2, 1, and 3. Oh wait, 4 for the last one.
So this again doesn't change. Vertical asymptotes don't change because it's shifted pi, its period is pi. But you do have to graph these new points, and you're just going to see a movement and a stretch, basically up or down with a little stretch. There's 0, 1, pi over 4, 4. Again, just and make sure you show just the ever so slight, it's not a straight line, it's got a little curvature to it like that.
Wait, where's the pi over 4 on the graph?
Right in the middle. I mean,
Okay.
0 and then minus pi over 4 is similarly right between there.
Okay.
Now, to be totally fair, there is way more to graphing tangents than this. Like, this is very much like a surface level, not a deep knowledge of this. So if there's the possibility that there's, excuse me, anything else on there that they're going to have you graph, like, please, we'd want to spend some more time on this.
Yeah, I think well, I think like in like a previous test we like graphed it, but then like he said like, oh, find the points like in between, and then we had to like write it out, like the vertical asymptotes. He was like, find 3 points.
Yeah, and there's things that can go on here with periods. There's reflections. Like, we're not doing everything, but these
Mhm.
are all fairly similar. So keep that in mind. Like, so I don't know. Sometimes I know you guys. There's someone's already taken it. Maybe you get some information from them and find out what's on it. Do your diligence. Make figure out what to do. Okay,
Yeah.
let's spend the last few minutes here working on logarithms.
Okay.
So the first problem here, and you do have, I believe you got the correct answer. Some calculators will actually just give you the answer, and I'm not
Oh,
opposed to you doing that, but I mean, just keep in mind you might get a problem. You can't do the calculator, so you might as well just show you by hand and show you with the calculator. Are you using a TI 8384?
no, I'm using a Casio.
Okay, I have no idea how to use a Casio, so I will not be any help on that.
Mhm.
At least for right now, I have to go to the internet. But the way to do this is to turn 64 into 4 to some power.
Mhm.
Okay. And it's okay to just try some numbers like 4 to the power of 1, 4 to the power of 2. You will eventually figure out what this is, if it works.
Okay, so just 3.
Yes. So this is really log base 4 of 4 to the power of 3. Now there's a property of logarithms that allows you to bring the exponent out in front. So this 3 actually comes out in front. It's 3 times log base 4 of 4.
Mhm.
Now there's yet another property of logarithms. When you have log base b of b, this equals 1. And an example would be like log base 2 of 2 is 1. When the base is the same as the thing you're taking the log of, it is 1. It could be log 13, 13. It's 1. So this part log base 4 of 4 is 1. The 3 is multiplying it, so your answer is just 3.
Okay.
All right, so let's take a look at another one here. Log base 3, 81. Your goal or the game here is to write 81 as 3 to some power. 3 to some power.
4.
It is 3 to the 4. Okay, so maybe you can use the same approach on the previous one and tell me what the result is.
Wait, what do you mean?
I'll just show you here. It was, so the first thing is you bring the exponent out in front.
Oh.
4 times log base 3 of 3. And
Mhm.
then because these are the same, the base and the thing you're taking the log of, because they're the same, it's just 1.
Mhm.
4 times 1 is 4.
Okay.
All right, so let's finish up your last problem here. Log base 2 of 64. Again, your goal is to write 64 as 2 to some power. That's the game.
6.
2 to the 6th. So this is really log base 2 of 2 to the 6th power. 6
Mhm.
comes out in front. 6 times log base 2 of 2. Because these are the same, it just equals 1. 6 times 1 is 6.
Okay.
All right. So we did get through kind of that first row of questions on there. Probably a good idea that you grabbed another lesson. I'm noticing that like 8 and 9 don't have any questions. So you might want to figure out what kinds of problems you had. I mean, we did piecewise, I think, on one of the previous lessons, so I can grab that. But